everyone, my name is Maria Elise and I'm with the University of Rhode Island's Inner Space Center. Right now I'm coming to you live from RV Endeavor located off the coast of Rhode Island. From now until September 6th, we're going to be streaming live with scheduled broadcasts at 11, 1, and 7. Those will be broadcast on Rhode Island PBS and also online at innerspacecenter.org/RIREX. Right now, I'm going to be talking to Dwight Coleman, who's the director of the Inner Space Center, and he's going to tell us a little bit about what we can expect to see on this cruise. Thanks for joining us, Dwight.
Hey, thanks, Maria Elise, and welcome to our live audience. We are live from the research vessel Endeavor, and we're about 30 miles south of Block Island, Rhode Island right now. And this ship that I'm on, the research vessel Endeavor, is part of the University of Rhode Island Graduate School of Oceanography. It's owned by the National Science Foundation, but operated by URI. And we've had the ship for about 40 years now, so it's on its, I think, 566th voyage, actually. And so we call this cruise EN566. And we have a multidisciplinary team of scientists on board. We're doing all sorts of different research. We're using ROV technology, remotely operated vehicles, to dive to the seafloor. We're hopeful to be diving on shipwrecks later today. Right now, we're pretty far from those shipwreck sites. We're south of Block Island, and we're doing some tests of the ROV. And in fact, one of the ROVs is in the water right now. We have a partnership with the U.S. Coast Guard Academy, and Rich Sanders and his student, Gabe Patterson, is operating an ROV, and they're navigating around the ship itself, actually. They haven't gone down to the seafloor yet. They're driving around the hull of the Endeavor, and they're going to take a look at the prop and the shroud and the hub of the main propeller for the Endeavor. So we may get a live feed from that in a few minutes. But this project is really to explore some of Rhode Island's shipwrecks and other resources off the coast of Rhode Island. We'll have a bunch of guests, engineers, scientists, students that we'll be talking with throughout the program, and we'll basically be broadcasting live 24 hours a day. You can go to our website and watch the live feed. And so we're grateful for the partnership with Rhode Island PBS and also all the other partners that have contributed to the success of this project. So that's what we're up to, and I'll toss it back to Maria Elise.
All right, thank you so much, Dwight. Next, we're going to be talking to Tom Rossby, who is a physical oceanographer, and Cody Fisher, who is a professor of electrical engineering at the University of Rhode Island. Thanks for joining us. Why don't you start by telling us a little bit about yourselves?
My name is Tom Rossby. I'm a professor of physical oceanography at the University of Rhode Island, Graduate School of Oceanography. I've been there for 40 years. My background, I'm an engineer. I like very much building and developing new ways of measuring ocean currents in particular. And over the years, we have focused very much on putting drifters or subsurface drifters in the ocean that move with the waters over great distances, like hundreds to thousands of kilometers, to see how water moves and disperses in the ocean. And the way we know this under the sea surface, since the radio waves don't work for navigation, we don't have GPS, we have our own acoustic navigation system, which is called RAFOS, Ranging and Fixing of Sound in the Ocean. And these floats listen every so often to signals that are being transmitted from fixed transmitters. These transmitters put out a very low frequency sound. Low frequencies propagate through the ocean very easily. So they go doot for several seconds, 32 seconds or 80 seconds, depending on the signal. And that signal has a very characteristic structure. So the floats are listening for precisely that pattern and can that way determine exactly how far away they are from the sound sources. This is something we have been doing for many years, and it's a technology that is used in this country, in Germany, in Norway, and it's a very effective way of seeing how stuff in the ocean moves around as a function of time. The reason we're here is, together with my colleague Cody Fisher, is that we're now trying to develop this, or port this capability, not to just tracking floats as they move through the ocean, but to track fish, believe it or not. And so Cody has for some time been focusing on developing that technology, and maybe you'd like to say a few words about that.
Thank you, Tom. Yeah, first of all, my name is Cody Fisher. I'm an electrical engineer. I'm also the chair of the Department of Electrical, Computer and Biomedical Engineering. And Tom and myself have been working on building gadgets for probably the last 10 years or so. And my field is electronics, integrated circuits in particular. And the challenge in the project, the reason why we are here, is to build a sonar receiver that is small enough that it can fit into a tiny package, which is about 1 inch long, a little cylinder, and about 3/8 of an inch in diameter. And to do that, there were two major challenges to overcome. Number one is how to make things very small, using microelectronics, obviously. And number two, also to reduce the power budget. The power budget that we have available is provided by a tiny watch battery. And to give you an idea how much power we need in order to operate our sonar system, this is about 2 million times less power than a typical light bulb will consume. And any more questions? I would be very happy to answer.
We do have a question. The question is, can this be used on other animals besides fish?
Oh, yes. Cody and I and a colleague in Woods Hole, Amy Bauer, we have received a grant from the National Science Foundation to port this technology that Cody has been developing into a next generation float so that we can make it smaller, and maybe even more importantly, we can make them less costly than have been in the past. The idea, and so at that point we can have both small floats in the ocean as well as tag fish, and actually look at how the fish are behaving in relation to the waters around them. So take, for example, out here on George's Bank, one fish that's of great interest is the excuse me, is the yellow-tail flounder. How does that behave in relation, or how does its behavior depend upon or relate to the currents that are taking place around the George's Bank? So I can see sort of biophysical couplings or connections between the technology that we have been using in the past just to study ocean currents with its application on fish to study how they're behaving in relation to the ocean around them. Typically, in the past, these are disciplines that have developed, independently. We have the fisheries sciences, we have chemical sciences, we have physical sciences. Now, one of the beautiful things about oceanography is they're really starting to be able to see connections between these fields and develop those connections and see how they interrelate. This is an aspect that's really making ocean sciences, I believe, very, very exciting compared to the past. So the science has evolved, but it's also getting a lot richer.
So what would you say to students who want to do what you do?
Yeah. I'm sorry, I didn't catch the question.
What would you say to students who want to do what you do, your kind of research?
Motivation for students.
Oh, well, number one is curiosity. I mean, it's the ocean is an incredibly rich area. There is so much that we don't know about the ocean. The ocean is impacting our lives, excuse me, on many dimensions in terms of just the health of the ocean, in terms of the ocean's impact on its role in climate control. That's a little bit more where my work comes in. I'm very interested in ocean circulation, and that means how do I transport, how does heat move around in the oceans. But along with the heat that we're moving around in the oceans, we're also moving around chemicals of various kinds. And along with the currents moving, for example, the American eel is transported by the Gulf Stream and other currents. So these are very, very fascinating questions, and just to be out here on the ship doing these activities is well, I'm one of the people who have used the ship the most, and I just find it absolutely fascinating to be out here and work on these questions. Specific questions are a little more difficult to answer. It depends on, a person's interest. I'm an engineer background, so I got my kicks as a young person developing the instruments. Now, as I have grown up a little bit more, I'm starting to see the science in a closer way than in the past. I just wish I could be a little younger.
So you ran a test of your equipment last night. Can you walk us through the steps that you would use?
Well, the test consisted of basically lowering a big sound source that is a cylinder of about 6 feet length and about a good foot diameter that produces a signature. And we have receiver electronics, which is a tiny piece of silicon that listens to the sound signature. And that is a specific pattern. And what we actually want to know is we want to know if the pattern has arrived, and we also want to know when the pattern has arrived. And to do that, we store a expected pattern of the signature that we had, in this case the sound signature, on board the chip. And the receiver detects an incoming signal and performs what we call a cross correlation, which is basically a comparison of the two patterns. And when the two patterns overlap best, that is our expected arrival time. So that was basically one exam we wanted to carry out yesterday. Can we detect the sound signature, and do we know exactly when it has arrived?
Excellent. So can you tell us what you're listening for in this experiment, what it sounds like?
Oh, yeah. Well, that was what I was trying to describe before. It's, in the early days with this technology, we had a very simple signaling system where the floats or the navigation system would come out with short toot, 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 and we would listen to those signals. But many years ago, a colleague of mine, Doug Webb in Woods Hole, came up with a scheme that was much more effective, namely sending out a signal that had a built-in pattern, which is what Cody was pointing out. And that allows us to, instead of sending signals short, we can send them over a long period of time at a lower energy level or level. And it's actually a system that's very similar to the radar systems that we have, police radars who are measuring the speed of a car. It's what we call a chirp system, a chirp signal, and we're listening for exactly a signal that has that particular chirp. So I said it sounds like a foghorn, doot, but it's actually, if I exaggerate, it's a doot. It has a certain sweep to it, and we're listening for exactly that pattern. And when you get that match, you can determine the arrival time, and thus the distances very carefully. This allows us to track how this stuff is moving around in the ocean with great resolution.
That is so cool. Well, thank you both so much for joining us. We're going to move on to our next guest, Mike Brennan, who is a marine archaeologist for the Ocean Exploration Trust. Thanks for joining us, Mike. Why don't you start by telling us a little bit about your background?
Sure. Hi, I'm Mike Brennan. I'm a former graduate student at URI's Graduate School of Oceanography. I did a PhD there in oceanography, so I've been out on Endeavor before. It was my first cruise in 2006. Now I work as an expedition leader for the exploration vessel Nautilus, which is owned and operated by Ocean Exploration Trust, and I'm their director of marine archaeology. So we've done a lot of exploration across the world. We started out in Turkey, working in the Black Sea, the Aegean Sea, and the Mediterranean, and in that time, over 2009 to 2013, we found 47 shipwrecks ranging in age from ancient Greek to modern times. Many of these were amphora cargo wrecks, so there's just a pile of the ceramic jars that held wine and olive oil, and we found them using side-scan sonar and then dove with the ROVs Hercules and Argus on those wrecks and mapped them and imaged them with our high-definition video camera systems. And then Nautilus moved across the Atlantic into the Gulf of Mexico and Caribbean Sea. And from there, we did some other shipwreck work, including the excavation of a 19th century copper-clad shipwreck called Monterey A. And we actually excavated that one, recovering some 50 artifacts for identification and preservation purposes. And last year, we actually worked on a U-boat site and some of the ships that it sank during World War II, the U-166. and the Robert E. Lee was a passenger ship that it sank off of the Louisiana coast near the mouth of the Mississippi River, and we were able to document some more of the wreck's features using our mapping systems. And it's interesting that we were at that U-boat this year, and there was a special by National Geographic and NOVA on it that came out this spring, because we're now going to be working on another U-boat that was sunk during the Germans' attack on America's shorelines in World War II. That's the U-853. So we're right now south of Block Island, where we're on an endeavor, and we're moving this afternoon north towards where the U-853 sank, which is to the east of Block Island. And we're going to be diving there at some point soon and doing a similar thing. We'll be looking at the integrity of the wreck with our ROVs.
What kind of life do you see on a wreck?
Sure. So wrecks are actually often used as reefs or artificial reefs. Oftentimes, concrete or metal and other structures are put down on purpose to create reefs for fish to aggregate on. Juvenile fish or smaller fish, like to use rocky substrates like concrete, or in some cases shipwrecks, either the ceramic cargoes that we find in the Aegean and Mediterranean, or steel-hulled or wooden-hulled ships that have sunk in more recent times. And so fish tend to aggregate around wrecks, which make them also targets for trawl nets and trawl gear. Because there's fish in the area, fishermen will sometimes go near these wrecks because they can catch them in their nets. A side effect of this is that these trawl nets often damage the shipwrecks, and so one of the things that we did in the Mediterranean area is we documented the trawl damage to the shipwrecks, which is a lot. These nets are weighted, and there's trawl doors, metal doors that keep the trawl nets open. So as the trawlers go over the top of these wrecks on the surface, and they drag their weighted nets behind, these doors carve furrows through the wrecks and damage the artifacts. Or on more recent wrecks like steel-hulled ships, they'll either catch their gear on the wreck and it'll pull off, entangling the wreck and losing the gear for the fishermen, or sometimes cut through parts of the wreck. So there's kind of a counterpoint to trying to preserve shipwrecks and also trying to manage our fisheries where there are shipwrecks, because there's kind of an intersection of the two disciplines there.
We have another question coming in from our live chat, and the question is, are there any constraints when you're diving on a shipwreck such as U-853?
Yeah, there are some constraints. So there's some international laws that apply here. One of them is that any ship that is a military craft, in case a U-boat it was part of the German military or the German Navy in World War II. Any of these shipwrecks are always the property of the home port. So the home nation of Germany owns or has the rights to protect the U-boats that sank, even though they're in U.S. waters. So we are only diving on the wreck, and I have notified the German embassy that we are doing this. We will not be touching or disturbing the wreck site at all, because it would only be with the German embassy's permission that we could do such a thing. We are also here just to eyeball or take a look at the site rather than touch it or recover any artifacts in any way.
So we have another question, and it's actually a two-part question. Have you looked at this wreck site before, and is there anything you expect to see when we're there?
I have actually not looked at this wreck site before. We have on board Captain Richard Sanders of the U.S. Coast Guard, who has been on the wreck as a scuba diver. So this wreck is in scuba diving depth, but we're using ROVs to take a look at it because it's safer for people, and it allows us to, through telepresence, bring more people to the site. So that's why we're using ROVs. I haven't been to the site before. We're expecting to see... we can take a look at the damage that the depth charges caused to the shipwreck. We can look and see what sort of fishing gear is caught up on the wreck, and we can also see some of the artifacts and other remains that are preserved on this wreck site.
Are there any environmental hazards associated with this wreck site?
Yes. So all shipwrecks have the possibility of fuel or oil escaping from their tanks after the sinking event. There's also, in the case of this U-boat, there can be torpedoes that have not been fired that are unexploded munitions. There's also some ordnance that has been documented at the site, which is an unexploded depth charge that never went off when it was dropped. So there are hazards and dangers of working at the site. It's something that scuba divers and trawlers who may accidentally go near the site need to be very careful of when working in these areas. So yeah, there are hazards and potential dangers of working at such sites.
So we have another question from a student, and it sounds like they're interested in what you do, and they want to know if there's anything they can do before college that's related to this sort of program.
Well, there's a lot that you can do before college. The answer that I often give to this sort of question is, as much as you might not like to hear it, get really good at the base subjects. So math and science and even writing is, believe it or not, very important for what we do. We may be scientists, but all of us have to write grants and papers about our work. So if you get, the point of grade school and even high school and college is to get a really good base understanding which you can apply to future classes. And once you understand the general concepts of how to write a good research paper or how to do the math that'll be associated with your work later on, that's one thing that you can do. And also try to take advantage of travel and other fieldwork opportunities so that you can get some experience in the field for the future work that you may want to do in college and or grad school once you figure out what else you want to do.
Well, thank you so much, Mike. We're actually going to go out on deck now because it sounds like something really neat is going on, and Dwight Coleman is going to tell you more about that.
Great, thanks, Maria Elise. So our cameraman, Kyle, is actually going to disconnect that camera and head out on deck, and we're going to take a look at what's going on out there. So right now we have our partners from the U.S. Coast Guard Academy, Rich Sanders and Gabe Patterson, a cadet. And Gabe is the ROV operator, and it's a small Seabotics ROV. This can basically be lifted by hand and deployed over the side of the ship. And they're going to rig it right now, and you'll see a live image from that in a few minutes of us getting set up. And then we'll launch that ROV in the water, and they're going to practice driving the ROV underneath the ship. And Shannon Donovan is our educator on board. She's a teacher at sea, Rhode Island teacher at sea. She's a high school teacher from Stewart, Rhode Island, and she's going to actually drive the ROV. So she already practiced once today, and she's going to do this again. So we'll wait for a second as Kyle gets set up out there. But for now, let's just sort of talk about ROVs in general. So we have two ROVs on board. We have one that's called Deep Reef. It's a CI Falcon ROV. It's much larger than the Seabotics that you're going to watch the deployment of in a minute. So the Falcon is our main ROV system, and it's operated by a team of engineers from URI, from the Department of Ocean Engineering. That department is on the same campus as the Graduate School of Oceanography. So they're part of the College of Engineering, but they're located on the Narragansett Bay campus where the Graduate School of Oceanography is located. So we, as GSO scientists, work very closely with the engineering department, and in particular the ocean engineering department, to operate technology, develop sensor technology, deploy the ROVs. And so Stephen Licht is a professor of oceanography. He's working on the Falcon ROV right now. He has his two graduate students with us, Matt Perkins and Jordan Kirby. So Jordan's the ROV pilot for the Falcon ROV, and that's the main ROV that we're going to be using to dive on the shipwrecks. But we've done a couple of dives down to the seafloor, or close to the seafloor, with this vehicle just recently, and we're developing what's called a ground fault. So there's some electrical problem that we're not quite sure what's going on with yet. So the engineers are actually working on that problem. They're trying to figure out what the problem might be. We actually we're plugged into a circuit on the ship that could have been causing one of the problems. The ship generates its own power, of course. There's generators on board, and then we have clean power right here in the main lab. And there's two UPSs, uninterruptible power supplies, that we need to plug into to give us clean power. So in order to operate all this technology around the ship, including the ROVs, including the telepresence system, we have to make sure that we have good power, enough power. And so what may have been happening is, as Jordan was driving the ROV and thrusting with full capacity, we may have been drawing too much power, causing a breaker to trip or causing a little electrical problem that we had to adapt to. So now we've actually made the adjustments to put that ROV control station onto a different electrical circuit. So we're hopeful when we dive that later today, we don't see the same ground fault problem that we had before. So I guess on deck, I'm trying to look at the camera here. So you see a feed coming from Kyle, who's set up out on deck, and they're launching that ROV in the water as we speak. So you see how easy it is to kind of lift up and deploy over the side. And I'm not sure Shannon's going to operate it now or not, but this is the Small Seabotics ROV that's owned by the U.S. Coast Guard Academy. Gabe Patterson, the cadet who's operating it, actually has dove this before off of a U.S. Coast Guard ship. The Coast Guard operates a research vessel called the Healy, and he actually did some dives with this same ROV off the Healy. So they are in the water now. You're looking at a live feed coming from its little camera, and going to drive around underneath the ship. And one thing that we want to do as part of this test and getting comfortable operating is actually look at the propeller of the ship. And so I'm not sure we'll actually get to see that right now, but there's Rich Sanders. He's our Coast Guard Academy professor, and his interests are largely in chemistry. He teaches chemistry at the Coast Guard Academy, but he also has a job to do with the Coast Guard, which is help with their environmental assessments of environmental assessments of potential hazards underwater, and some of those environmental hazards are shipwrecks themselves. As the steel hulls of ships deteriorate, they pose a potential environmental threat and can leak oil into the environment. The U.S. Coast Guard has the responsibility to respond to oil spills of all kinds, and so these shipwrecks are potential hazards in that they could start leaking oil. That's been very well documented at the USS Arizona, which is in Pearl Harbor, that sank during the attack on Pearl Harbor, and it's been slowly leaking oil into the environment since it sank. So that's a well-studied site, but Rich is part of a group that does this for the Coast Guard, and part of his research is trying to understand more about the marine environment when the ships sank, and trying to assess the potential hazards associated with those shipwrecks. So now we have a live feed looking at the ship. The ROV is driving underneath it, so you can see the bottom of the Endeavor as we're talking to you live here. So the ROV the camera can tilt up a little bit, so they're driving several, probably 10 or 20 feet below the ship, with the camera tilted up so that they can look at the hull of the ship silhouetted there as they're riding on the surface. So the person operating the ROV right now is Shannon Donovan, the teacher from Scituate High School, and she's standing there next to Gabe Patterson from the Coast Guard Academy, who's sort of giving her some instruction and coaching on how to operate the technology. It's basically a joystick. It's almost like playing a video game. You can drive forward and aft and side to side and up and down and spin the heading of it. So it's got these little thrusters on it that can propel it through the water. And then you have a little control system for the camera, where you tilt the camera up and zoom in and zoom out and use it to navigate. So, Shannon learning how to operate this ROV. So Kyle's got zoomed in on her control stick. So you see what that can, a little bit more sophisticated than you might know from an Xbox controller or something like that. But it's basically the joystick. She's pushing it forward to give it forward thrust. One of the challenges of doing all this, of course, is how to keep the ROV stable and steady and moving against the current. There's pretty swift currents out here. There's pretty swift currents out here that are challenging for an ROV operator to drive against. So we're going to wrap this program up. So I want to thank everybody for watching. And what we're going to do is have this broadcast going live out to our website. So you can go to interspacecenter.org/RIREX, learn more about the project, of course, but also watch the live feed. We're broadcasting 24 hours a day. So we want to thank everyone for watching, and it's been a great program. I'm happy to be with you, and please tune in again.